My name is Odin Appleby and I will be talking about steady state exercise. Definition of steady state exercise is when your body is producing lactic acid at the same time it's removing lactic acid. This is an aerobic exercise because oxygen is used to remove lactic acid. This happens when you're working between 60 to 70% of your maximum heart rate. An example of this being executed in a gym is running on a treadmill or riding a bike. This is because it allows you to set the pace that you're going at. Cardiovascular system affects steady state exercise. Things in cardiovascular system which affect steady state exercise are stroke volume, blood pressure, vasodilation, and thermoregulation. Heart rate increases because the heart is working harder to oxygenate the working muscles. As the heart rate increases, so does the stroke volume. This is because the blood is getting forced against the walls of the arteries. Both of these occur to keep up with the demand of oxygen that the body needs. Vasodilation is important to steady-state exercise. This is because the temperature affects the performance of an athlete. The body tries to control the temperature by thermoregulation. Vasodilation happens when the arteries bring the blood closer to the surface of the skin to cool it down. Cardiac output is the amount of blood pumped from the heart per minute. If I was going to show cardiac output on a graph, it would go straight up and then it would level out. This is because when you're doing steady state exercise, you work at a constant pace. This is the responses of the respiratory system. Tidal volume is the amount of air you can breathe in one gasp of air. Tidal volume increases to meet the demands of oxygen the body needs. Something which also increases is the breathing frequency. The breathing frequency increases because your body is trying to get oxygen to the lungs so it can be passed on to the working muscles. This is the oxygen dissociation curve. This part shows you how much oxygen there is in the air. This part shows you how saturated is the hemoglobin. When there's 100% of oxygen in the air, there's 100% of oxygen in the lung. That means there's 100% of saturated hemoglobin. This part of the graph shows you how much oxygen there is in the working muscles. So how much oxygen there is in the air have an effect on how saturated is the oxyhemoglobin. There are a few things which affect the graph, and you can see by these lines there are shifts in the graph. This affects by the pH levels and the temperature. Also, this graph is similar to the breathing frequency graph because the breathing frequency goes up and then it levels out because of steady state exercise. This means you're working at a constant pace. When the graph shifts to the right, it shows you there is an increase in carbon dioxide. That's why the pH level changes. This tells the chemical receptor in your neck that you need to breathe more. This is also a reason why the breathing frequency increases. And when the graph shifts to the left, it shows you that the temperature decreases, having an effect on the performance of the athlete. Steady state exercise affects both the joints and the nervous system. Steady state affects the joints by releasing more synovial fluid into the joints to make it move more freely. While exercising, the body gets warmer, and when this happens, the nerves moves faster. This is because the path which they travel has been lubricated. This improves your reflexes. The energy system used for steady state exercise to happen has to be efficient and work at a low intensity. This is because the body will be able to cope with the demand of oxygen. This is the aerobic energy system. This happens by breaking down glycolysis into pyruvate, which then reacts with acetyl coenzyme, which is created in the mitochondria. The reason for this is to create more ATP so the energy cycle can keep going. The mitochondria is the site of energy production aerobically. This is because they are specially folded cristae made to have a larger surface area so more energy can be produced. There are different amount of ATP produced in each cycle. In the anaerobic cycle, there are 2 ATP produced. The picture shows that there is 2 ATP produced because lactic acid is the finishing product and there is no oxygen used. Krebs cycle is when coenzyme reacts with different compounds to produce ATP. This also produces 2 ATP. And the last cycle is the electron transfer chain. This is when the hydrogen from the Krebs cycle reacts with oxygen to form ATP. This produces 34 ATP.